Okay, 17A. So, for some reason the axes got a little messed up on here. We've got 2, 2. We have 3, 6. We've got 5, 6. And 4, 2. So the first thing you want to do is identify what type of shape this is, because then we'll know what formula to use. So we identify this as parallelogram. Very good. So the area for a parallelogram is base times height. That's all there is to it. You may count the boxes. You have permission. 1, 2. The length of the base is 2. And then where is the height? That's what you have to be careful of. Remember, the height is never slanted. That's the side. So what you do is you go to a vertex and you drop an altitude. That's what it's called. You drop an altitude. Could you have gone here and dropped this altitude outside? Absolutely. Altitudes sometimes fall outside the shapes. These are going to be the same height either way. 1, 2, 3, 4. Wow. Wasn't that beautiful and easy? 21 is just a fancy way of asking what is the length of PQ. It's saying find PQ, but in a real world context. Okay? So you do need to be able to find missing side links on these. We call them composite figures. It's not a rectangle, but it's a figure made up of multiple rectangles. So what I recommend you do is get like a highlighter out or a color out, and you can find missing horizontal and vertical segments by finding the other horizontal or vertical segments. What I mean by that is you can highlight everything that's horizontal. And then you can kind of see, whoa, that's cool. You can see how the pieces line up. These pieces together make 22 feet. So it's like part plus part plus part equals whole. And by highlighting, I can see what I'm supposed to add together to get the final one. Okay? So the distance from P to Q is 9 feet. So what's the maximum width the mirror can be? If you're going to shimmy it in there, it can be a 9 full feet. You probably want to get one that's a little bit smaller than 9 feet. Or else you might get it'll be hard. 8.9 repeating. There you go. Okay.